Hello and welcome to our first video for pre-calculus. We're going to be studying for our first chapter, the chapter titled Prerequisites. So these are all skills that you should have seen before and that you should be familiar with. Things that you did in Algebra 1 and Algebra 2 that we're now just looking to practice and to refresh before we get into the actual pre-calculus curriculum. So if we look at the first thing it talks about here is algebraic expressions. And the terms of an algebraic expression are separated by addition. Some people say by addition or subtraction. Some say just by addition, since we know from studying integers that we can change addition to plus the opposite. So if we do that here in that algebraic expression, you can see now that all of our terms are separated by addition. So in this case, we have four terms. 1, 2, 3, 4. So those four terms would be 7x, negative 9y, z, and negative 3xy. It's important that you can identify the different terms of an expression so that we can then take the terms and add them whenever they're like terms. Now the coefficient is the numerical part of a term. So once you've identified the terms, the coefficients are simply the numerical parts. So in the terms we already identified, the coefficients would be 7, negative 9, 1, and negative 3. Like terms are terms that have exactly the same variables. So if you look at what we've already looked at, this expression that we started with here, there are no like terms. So I'm going to make up a term and a like term. So let's say I say negative 3x squared yz. And then my other term might be 150x squared yz. And let's make another example. Let's take negative 5a and 12a. Now the thing you want to be careful about, I'm going to put over here, not like terms, is even if it has the same variables, they also need to be raised to the same power. So these two would not be like terms. Let's say we have negative 10 x squared y squared z squared and 18 x y z. Even though those both have x, y, and z in there for the variables, they're not raised to the same power, so they are not like terms. Okay. When simplifying algebraic expressions, we still follow the order of operations. So when we fill these in, P stands for parentheses, or it can be brackets. E stands for exponents, which is also roots. M is multiplication. D is division. Now you do multiplication and division at the same time. From left to right, just like you're reading. So they go at the same time. You don't go through and do all the multiplications in a problem and then do all the divisions. Do them at the same time as you're moving from left to right. Same thing is true with our last two, addition and subtraction. Those are also at the same time from left to right. And often we're told to remember the order of operations using "please excuse my dear Aunt Sally." So that might sound familiar to you. Now, when they ask you to simplify the following, we're going to follow the order of operations first. So I'm going to first look inside the parentheses. These are not like terms, so I can't combine them. And these two are not like terms, so I can't combine them. You have two terms here. You had two terms in the first one. You can't combine them because they're not like terms. So that takes care of our parentheses and brackets that we're supposed to do first. We can't do anything with the exponents or roots because the exponents are on a variable. So we're going to go to multiplication. So we're going to use the distributive property and multiply here first and get 12x cubed plus 24x squared. And then I'm going to use this plus 10 and distribute it also. So we get 40x squared plus 30. And now I'm going to add and subtract. So when I'm adding or subtracting, I'm using like terms. There's only these middle like terms, so I end up with 12x cubed plus 64x squared plus 30. Now the second example again is similar. Inside our parentheses, none of our terms, here we have three like terms, none of them are, or I'm sorry, three terms, none of which are like terms. And in the second parenthesis, two terms which are not like terms. So now we're going to go to that distributive property here. So we get negative 12x cubed plus 6x squared y plus 15x squared. And be careful here with this minus, we want to distribute it as well. So I'm going to get minus 6x cubed plus 8x. And then we're going to combine our like terms. So I'm going to combine this x cubed with this x cubed and get negative 18x cubed. And then we get plus 6x squared y plus 15x squared plus 8x. And since there's no more like terms, I can't simplify that any further. So now if we look at that next example, I'd like you to pause the video, try the next two examples, and then I'm going to work through them. So you can either watch me work through them to see if you got the right answer, or you can fast forward to the answer and see if you got it correct, and then go back and see where your mistake was if you missed it. So for this next one, again, we're going to do distributive property. So I'm going to distribute this 5 in here. And we're going to distribute this plus 3 here. So I get 10xy minus 15y minus 4 plus 6x plus 12y. And then I'm going to look for like terms, which the only like terms I have are these terms with a y in. So I'm going to start with my x. So 6x plus 10xy, and now I'm going to put the y term I get, so minus 3y minus 4. Now, if you wrote those in a different order, that's fine. They usually say that standard form is when your exponent's decreasing. In this case, all our exponents are 1, so the order that you write them in is kind of up to you. I tend to try to go alphabetically as much as I can, if I can't do it with the exponents in descending order. For the second one, I'm going to distribute this negative 2 across here and this plus 4 into the 2x squared y. Notice that's only one term, so I'm only multiplying that term by 4. So we get 8 minus 6x squared plus 6x plus 8x squared y plus 7. If I look for like terms, my only like terms are my constants. So I'm going to get negative 6x squared plus 8x squared y plus 6y, and then we get plus 15. And again, if you wrote that in a different order, it's fine as long as the signs on each of your terms are the same as the signs on my terms. Okay, let's look at the next part of the notes. This is a review for the properties of exponents. So it tells us to let a and b be any real number, numbers, variables, or algebraic expressions, and let m and n be integers. Remember, integers are positive and negative, whole numbers, and 0. Assume all denominators and bases are non-zero. So if we look at the first one, if we have the same base, in this case it's represented by a, and we have it raised to two different variables, and we're multiplying, then two different exponents, we can add those exponents. So we can say that's equal to a to the m plus n power. Whereas if we have the same base in example B, different exponents, and we're dividing, we can combine this and say it's a to the m minus n power. In letter C, this is called power to a power rule. In this case, we're going to multiply those exponents, so m times n. In letter D comes about, and we use it often because it's not really considered mathematically correct to have a negative exponent. So to make that a positive exponent, I flip it over the fraction bar. So if we consider that this is over 1 and I flip over the fraction bar, I get 1 over a to the positive n. Anything raised to the 0 power is 1. In this next one, we're looking at having more than one number or variable expression raised to a power. So we're going to raise both of those to the power. So this turns into a to the m times b to the m. And when we're dividing, it's the same thing. We're going to get a to the m over b to the m. You need to make sure you raise both of those parts of the expression to the mth power. So let's look at some practice with these. So in letter A, we're looking at that rule where we have two things inside the expression and we're raising them both to the negative third power. So I'm going to write this as 3 to the negative third over 4 to the negative third. Then we fall back on the rule about negative exponents, which aren't considered mathematically correct. So we're going to flip that term over the fraction bar. So I'm going to flip the 3 to the negative 3 to the bottom and make it 3 to the third, and the 4 to the negative 3 to the top and make it 4 to the third. And then if we actually calculate what those values are, we get 4 to the third is 64 and 3 to the third is 27. In letter B, this is if you look at B and C, this is where the order of operations comes into play. And I actually have a story to tell about this. When I was interviewing for my job here at State College, they asked me letter B and letter C as one of my questions to see if how well I knew my mathematics. And so the key here is to remember that in order of operations with PEMDAS, please excuse my dear Aunt Sally, exponents comes before multiplying. All right, so in letter B, we have to do the exponent part before we do that multiplying by that negative, because it's really negative 1 times 2 to the 4th. We just don't write the 1 in there, it's implied. So I'm going to do the 2 to the 4th first. So 2 to the 4th is 16. So then we get negative times the 16 should give you negative 16 for an answer. Now the difference between B and C is if you look at C, the negative 2 is in parentheses, which means you're taking that whole amount of negative 2 and raising it to the 4th. So we're really taking negative 2 times negative 2 times negative 2 times negative 2. And because we have an even amount of negatives that we're multiplying, it's going to come out positive. So this actually comes out to positive 16. If we look at letter D, here we're looking at taking our bases and combining to simplify. So the first thing I'm going to do is look at the coefficients, and I'm going to reduce 4/12 to 1/3. And then remember, when we're dividing and we have the same base, I'm going to use a different color here. So my base here is A and my base here is A. When we're dividing, we subtract the exponents. So I'm going to do A to the 3 minus negative 2. And then for the B base, this is implied that it's 1 here. We're going to again subtract. So I'm going to do B to the negative 4 minus 1. Now if I simplify those, I get A to the 5th, B to the negative 5th over 3. And then I can't leave that as my answer with that negative exponent. So I'm going to flip my B to the negative 5th to the bottom and make it b to the positive fifth. And that would be my final answer then. If we look at letter E, we're going to take the squared. Okay, we're going to start with the parentheses first. I'm going to start with this squared out here. And remember, we have to raise everything in the parentheses, all the different values and variables in there to the squared value. So I'm going to start out with -3 quantity squared, a to the -5th squared over a to the 0 squared, b to the 4th squared. And now I'm going to simplify this. So -3 squared is +9. I get a to the -10th. This is power to a power, so you're going to multiply those exponents together. When you take a term and you raise it to a power, you're going to multiply those exponents. Same thing in the denominator. We get a to the 0, and I get b to the 8th. Now again, I can't have that negative exponent. I also know that a to the 0 is really 1, so I'm going to replace that with a 1. So I'm going to get 9, and then I'm going to have a to the 10th, flip it to the bottom to make it positive, and b to the 8th still in the denominator. If you're getting a hang of these and you want to try some on your own, feel free to pause the video and then come back and check your answers. So in letter F, I'm going to first take this second parenthesis and use my second power, raise everything in that parenthesis to the second power. So we get 4 squared, a to the 8th over a to the 14th, b to the 4th. Now I'm going to combine as I'm multiplying here with my parenthesis times parenthesis. This is multiplying. So in my numerator, I'm changing the 4 squared into the 16, a to the 8th. And in the denominator, I get 3. And then when I multiply my a to the -2 and my a to the 14th, I'm going to add those. When you're multiplying the same base, you add the exponents. So I get a to the 12th and b to the 4th. And now I'm going to do one further thing to simplify. I'm going to look here and say these are the same bases, so I'm going to subtract my exponents. So I get 16, and when you do that subtraction, your answer goes in the numerator. So when I do a to the 8 minus 12, and then it's a 3 times b to the 4th, and when I simplify, I get 16a to the -4 over 3 b to the 4th. And then one last step, move that negative exponent to the denominator. So 3 a to the 4th, b to the 4th. Okay, I think we just have a few more examples, 3 more to do. So again, first thing I'm going to do is take this second power and take everything in this parenthesis, this term in this parenthesis, raise each part to the second power. So I'm leaving my first term alone, the second term, raise it to the second, so 4 to the second, a to the second, b to the -6. Now, I'm going to combine here. We're multiplying, so I'm going to take the -3 times the 4 squared. So -3 times 16 is -48. And then remember, when you have the same base and you're multiplying, you add the exponents. And it's implied there's a first power here, so I add that with the second power. I get a to the 3rd power, and I've got my b's here, b to the 4th. So I'm going to do 4 minus a -6, which gives me, I'm sorry, not minus, plus. So we're going to do, let me change that there. We're going to do 4 plus -6, which gives me -2. So now to finally do my last simplifying step, I've got to get rid of that negative exponent. So we're going to do -48, a to the 3rd, and put the b squared in the denominator. Notice here, this is a little hard to read on mine. I hope you can see that that's a -3. So I'm going to raise everything to the -3 power. So -2 to the -3, x, we're going to multiply here. So negative 2 times negative 3 is positive 6. And y, we're going to do 2 times negative 3, which is negative 6. Now I'm going to take my negative exponents and move them into the denominator. So we're going to get negative 2 to the third, y to the sixth, and our x to the sixth stays in the numerator. We're going to go a little further here. I'm going to do negative 2 to the third, so that's really negative 2 times negative 2 times negative 2, so that gets me negative 8 y to the sixth, and that's my final answer. And for the last example, we're going to raise everything to the 0 power. Now if I take anything to the 0 power, it's 1. So since I can take this whole expression and raise it to the 0 power and say that it's 1. This is kind of a shortcut. So I get 3a to the third for my answer. Now if you didn't realize that and you took everything to the 0 power, you'd get negative 4 to the 0 and a to the 0, because you would multiply the 2 times the 0. Both of those are going to turn into 1s, but you're still multiplying by that 3a to the third, so you would still end up with the same answer. Hopefully this brought back some memories of the exponent rules and combining algebraic expressions, and you'll feel confident when you're working on them in class tomorrow.